Hello there, Mr. Sutton here, bringing you the IM3 Chapter 6 Quiz 2 review solutions on adding and subtracting rational expressions. To add these rational expressions together, we're first going to check to see if we have a common denominator. It looks like we do. These are both 40. So we can go ahead and actually just add the numerators and keep the denominator. Let me keep my denominator of 40, and then adding my numerators, 7x plus 23x is going to give me 30x. Let me just double check now to see if I can reduce this a little further. So 30 and 40, those are both divisible by 10. So if I reduce those, I can make this 3 over 4. Next, let me clean up what I have in the numerator. That's just going to be 3 times x. And in the denominator, all that's left is that 4. To simplify this rational expression, I need to add all of these together into a single fraction. But before I can do that, since I have different denominators, I am going to need to get a common denominator, the least common denominator if I can. So to figure out the LCD, let's first look at the numbers, the coefficients, 6, 3, and 9. And I want to find the smallest number that those all go into. So to make my life easier, I'm just going to take the biggest of those, 9, and start looking at multiples of 9 until I find a multiple of 9 that is also divisible by 3 and 6. 9 itself is divisible by 3, but not 6, so the next multiple of 9 is 18. That is divisible by both 3 and 6. So 18 is what I'm looking for coefficients. Now for variables, at least one of these has an x. They all do, but even if just one of them had an x, I would have to include the x in the LCD, since this has enough factors in it to cover all of your denominators. All right, so at this point, I'm going to try to get each of these denominators to be 18x. To do that, I'm going to multiply each fraction by a fancy form of 1, a number over itself. Whatever number is going to give me 18x in the denominator. So for the first fraction, to figure out what I have to multiply this by to get 6x into an 18x, we can divide 18x by 6x. That'll give us 3. So 3 over 3 then, if I multiply by that, that would give me 18x down there. And then to turn the 3x in that next fraction into an 18x, I'd have to multiply by 6 over 6. And finally, the last fraction, to get 9x to be a 18x, that would be 2 over 2 that I'm multiplying by. Let's actually go through and multiply these. So for the first fraction, I've got 21 over 18x. Then I have a plus 5 times 6 is 30 over 18x. And finally, we have a plus 16 over 18x. Now I can keep the 18x as my denominator when I combine all these and just add the numerators together. So 21 plus 30 is 51. 51 plus 16 gives me 67. Just doing a quick double check here, there's no numbers that I can divide both 67 and 18 by. I mean, if you're suspicious about 3, 6 plus 7, the digits up there do not add up to something that's divisible by 3. So really, there's nothing we can do here except end the problem. To simplify this expression, since I'm adding or subtracting rational expressions, I have to first get a common denominator. Now the good news is it looks like we've already got the same denominator. So I can just keep that denominator and then just add or subtract the numerators. So upstairs, I'm going to just rewrite things now. We have a 6x plus 14. And then I'm subtracting this whole numerator. So we got to be careful. I have to distribute a negative 1 to everything up there. So we have a minus 2x and a minus minus or plus 6. Now I'm just going to combine like terms up there, and I'll rewrite my denominator. So upstairs we have 6x minus 2x, that's 4x. And 14 plus 6 gives me 20, so plus 20. When you've added or subtracted, you should always double check to see if you can factor and reduce a little bit more, because you're not going to know it until you get to this point. It looks like I can factor a 4 out of that numerator. So we have a 4 parentheses x plus 5. And we might as well factor the denominator to see if there's anything that we can cancel there. So let's see, factors of negative 15 that add up to 2. Well, 1 and 15 doesn't work. 3 and 5 does if you have negative 3 and positive 5. So x minus 3, x plus 5. And lo and behold, those x plus 5s actually do end up canceling. So then we have a 4 over x minus 3. And now this is fully simplified. To simplify by adding these expressions together, I need to get a common denominator. Before I can do that, I need to factor my denominators so that I know which factors are going into the LCD. So the first one here, I can take out a 12, leaving me with x minus 2. And then for this other denominator, it looks like I can take out an 8. That leaves me with an x minus 2 there as well. For the LCD, that's the smallest thing that both of these go into. I'm going to start with the 12 and the 8, and I'll do the other factors separately. So I'm looking for the smallest number that 12 and 8 both go into. Well, does 8 go into 12? Maybe we already have the LCD. It does not. The next multiple of 12 is 24, and 8 does go into 24. So it looks like 24 is going to be part of our LCD then. Now let's deal with the other factors. We definitely need an x minus 2 included in there. And we also, well, actually there's nothing else. There's another x minus 2 here, but we've already covered it with the x minus 2 from the first denominator. So just kind of a quick guideline for LCDs if you're having trouble here. You're basically looking for the smallest expression that would cancel out each of the denominators. You're not trying to cancel out denominators, but if you wanted to, that's just kind of a way of thinking about it that gets you the LCD. And you only need more than one of these factors if it appears more than once in a denominator. Since the x minus 2 appears at most once in each denominator, that's why we only have x minus 2 here rather than x minus 2 squared or anything like that. Now that we've got the LCD, we're going to multiply each fraction by whatever it needs to get us this LCD in the denominator. So for my first fraction, I've already got the x minus 2, but this 12 needs to be a 24. So to get that, I'm going to multiply by 2 over 2. And I have to multiply by something over itself because I can't change the value legally of this. So I have to multiply by, I call it a fancy form of 1, a foo. Basically, just multiplying by 1 doesn't change the value. For this other fraction, I've already got the x minus 2, but this 8 needs to be a 24. So I'll multiply by 3 over 3 to make that happen. Let's actually multiply now. So 7 times 2 gives me 14 in that first numerator. Downstairs, I've got 24 x minus 2, which is what I was aiming for because we were trying to get the LCD down there. For the second fraction, 12 times 3 gives me 36 up there. And again, we have 24 x minus 2 downstairs. Since I now have the same denominator, let's keep that denominator and just add the numerators. 14 plus 36, that's going to be 50. And once you've added these, double check to see if you can reduce. 50 and 24 can be reduced. Those are both divisible by at least 2, I think. So that would give me 25 up here and 12. 24 divided by 2 is 12 downstairs. So when the dust settles, then we have 25 in the numerator and 12 parentheses x minus 2 in the denominator. Now, it might have been possible to reduce this second fraction at the very beginning, and maybe that would have helped us out a little bit more, but hey, we're here now, and we've got our answer. To simplify this rational expression, we need a common denominator since we're adding or subtracting here. And I need to factor this lower left denominator so I can see what factors there are, and hopefully x minus 3 is one of them, but we never know. So factors of negative 27 that add up to 6. Well, not a lot of options. There's 1 and 27, which does not work, and there's 3 and 9. 3 and 9 works if you have negative 3 and positive 9, so x minus 3, which is what we were hoping for, and x plus 9. Our LCD then is going to have an x minus 3 in it, and also this x plus 9, and we only need one of these x minus 3s because it appears at most once in any of the denominators. So now let me multiply each fraction by whatever it needs to get this LCD. The first fraction is actually fine the way it is. We don't have to multiply that by anything since we've already got the LCD down there. For the second fraction, however, we've got the x minus 3, but we still need an x plus 9. So to get that, I multiply by x plus 9 over itself. And I have to do it over itself on both the numerator and denominator because I'm really just multiplying by 1, so I'm not technically changing the value, which would be illegal if I changed the value of something. All right, so our first fraction, we can leave that the way it is for now. We do have to multiply the second one out, though. So distributing my x to x plus 9 in the numerator, I've got an x squared plus 9x. And in the denominator, I now have the LCD of x minus 3, x plus 9. Since I've got the same denominator, let me just keep that. And now let me add the numerators together. So we've got an x squared, we've got a plus 9x, and then we just got a negative 36 kind of along for the ride. There's no like terms, so we can't simplify that at all at this point. However, now that we've added things together, let's see if we can factor and reduce this at all. You should always check. So factors of negative 36 that add up to 9. Well, let's see. We've got 1 and 36 doesn't work. 2 and 18 doesn't work. What's next? 3 and 12. Well, that might work if I had negative 3 and positive 12. So we've got an x minus 3 and an x plus 12. And sure enough, those x minus 3's can cancel, leaving me with an x plus 12 over x plus 9.